In this session, we are going to learn the basics and syntax of PHP. Before starting to write PHP code, it's important to understand the environment needed to run it properly. Students will first learn about the system requirements for running PHP, such as the web server, PHP version, and supported operating systems. After that, we will discuss how to install PHP on different platforms like Windows, Mac OS, and Linux. Understanding the installation process helps you set up your own PHP environment correctly so you can start practicing without issues. Next, we will outline the basic concepts of PHP, explaining what PHP actually is and how it works as a server-side scripting language. You will learn about different PHP tags, which are used to write and execute PHP code inside HTML. We'll compare these tags and understand which ones are most commonly used in real projects. You will also explore how PHP interacts with HTML to create dynamic web pages. Unlike static HTML pages, PHP allows us to add logic, process data, and display dynamic content. This is the key feature that makes PHP so powerful in web development. After that, we will go through the steps of writing and running your first PHP script. You will see how to save your code with a .php extension and run it through a local web server such as Apache or XAMPP. Finally, we will cover how to add comments in PHP. Comments are important because they help make your code readable and easier to understand for yourself and others. Overall, this session gives you a complete starting point to begin your PHP journey. You will learn how to install PHP, understand its syntax, write basic scripts, and see how it connects with HTML. By the end of this lesson, you'll be ready to start coding in PHP with confidence. In this part, we will discuss the installation of PHP and the basic system requirements needed to run it successfully. Installing PHP locally on your computer allows you to securely create, test, and run PHP-based web applications before uploading them to a live server. This is an important step for every web developer because it ensures that your website or web application works correctly in a safe testing environment. To run PHP, your computer must have three main software components installed. The first is a web server, such as Apache, which acts as a platform for hosting and executing PHP code. The second is the PHP interpreter, which is responsible for processing the PHP scripts and generating the output that is displayed in the browser. The third is a database, commonly MySQL, which is used to store and manage data for dynamic websites. Although the database is optional, it becomes essential when you are developing practical, real-world applications that require data handling. You can install each of these components separately from their official websites, but that can be time-consuming and sometimes complicated for beginners. To make the process easier, open-source developers have created all-in-one software packages such as WAMP, LAMP, and XAMPP. These packages automatically install PHP, Apache, and MySQL together in one setup, saving time and ensuring proper configuration. The package you choose will depend on your operating system. WAMP for Windows, LAMP for Linux, and XAMPP for any platform including Mac OS. All three, Apache, MySQL, and PHP, are open source and form the foundation for creating dynamic and interactive websites. PHP works as the scripting language that connects with the MySQL database to access, process, and display information dynamically on your web pages. Together, these technologies make it possible to build high-performance, data-driven web applications easily and efficiently. Now that we've understood the importance of installing PHP and its system requirements, let's look at some of the most popular software packages used to run PHP smoothly. LAMP. WAMP and MAMP stands for Linux, Apache, MySQL, and PHP. It is the most commonly used technology stack for developing and deploying web applications on Linux-based systems. This stack provides a reliable environment for hosting and running PHP-based websites. Apache acts as the web server, MySQL handles the database, and PHP is the scripting language that connects the two to generate dynamic content. WAMP, on the other hand, stands for Windows, Apache, MySQL, and PHP. It is essentially the Windows version of the LAMP stack and is widely used for web development and testing on Windows computers. WAMP is usually installed as a single software package that bundles all three components, Apache, MySQL, and PHP, together. This makes it much easier for beginners to set up a local web development environment. The main purpose of WAMP is to help developers build and test their websites locally before uploading them to a live server. However, WAMP can also be configured to host live websites if needed. WAMP supports dynamic websites, integrates easily with PHP, and comes in both 32-bit and 64-bit versions, allowing flexibility depending on the user's system. Similarly, for macOS users, there is MAMP, which stands for macOS, Apache, MySQL, and PHP. MAMP is essentially the equivalent setup of LAMP and WAMP, but specifically designed for Apple computers. Before starting PHP development, it's essential to make sure that a web server is installed and running, either locally or online. The web server is necessary because PHP code cannot be executed directly by your computer. It must be processed by a server where the PHP interpreter runs. This is why tools like WAMP, LAMP, and MAMP are so helpful. They provide a complete server environment that allows you to test your PHP scripts safely on your local machine before going live. When learning PHP, it's important to understand that the tools required to run PHP can either be installed separately or together as a complete package. While each component, such as Apache, MySQL, and PHP, can be downloaded and configured individually, developers usually prefer to install them together in a bundle. This approach saves time, avoids compatibility issues, and allows for faster productivity, especially when setting up a local development environment. The most commonly used software bundles for PHP are LAMP and WAMP. LAMP stands for Linux, Apache, MySQL, and PHP. It is one of the most popular solution stacks for running PHP-based web applications on Linux operating systems. The LAMP stack provides a stable, open-source environment that supports the full development and deployment process for dynamic websites. Each component in LAMP serves a key purpose. Linux acts as the operating system. Apache serves as the web server. MySQL manages databases, and PHP works as the scripting language that connects everything together to build interactive web pages. For Windows users, there is WAMP, which stands for Windows, Apache, MySQL, and PHP. WAMP is essentially the Windows version of the LAMP stack and comes as a ready-to-install software bundle that includes Apache, MySQL, and PHP pre-configured to work together. The main purpose of WAMP is to make web development and internal testing easier. It allows developers to create, test, and run websites locally before publishing them online. Additionally, WAMP can also act as a local web server, meaning you can use it to host live websites temporarily on your own computer for demonstration or small-scale testing. WAMP supports dynamic website development, is highly compatible with PHP, and is available in both 32-bit and 64-bit versions. This flexibility ensures that users can set up their local server environment efficiently, regardless of their system configuration. Overall, whether you use LAMP on Linux or WAMP on Windows, both provide a complete and convenient solution for running and testing PHP applications locally, making them essential tools for every web developer. Now let's move on to another popular software package called XAMPP. XAMPP is one of the most widely used tools for setting up a PHP development environment. It is an open-source, cross-platform web server solution stack that includes all the necessary components required to run PHP smoothly. XAMPP comes with the Apache HTTP server, the MariaDB database, and the PHP interpreter. The best part about XAMPP is that it's completely free and works across multiple operating systems such as Windows, macOS, and Linux. MariaDB, which comes with XAMPP, is a community-developed version of MySQL. It functions almost the same as MySQL but has been designed to offer better performance and reliability. This makes XAMPP a powerful and modern alternative for both beginners and professionals working on PHP-based projects. One of the biggest advantages of XAMPP is its simplicity and flexibility. It allows developers to easily transition from a local test server to a live server because most web hosting services use similar software components as XAMPP. This means that any website you build and test on your local computer using XAMPP will likely work the same way once uploaded to an online server. XAMPP also helps developers quickly create, test, and deploy their PHP programs without needing to configure each component manually. It provides a graphical control panel to start or stop Apache and MariaDB services with a single click, making it very user-friendly. Because of this, XAMPP is often preferred by students and new learners who are beginning their journey in web development. In short, XAMPP offers a fast and efficient way to deploy LAMP or WAMP-style setups on any operating system. It provides a complete environment for PHP development and testing without any complicated setup process. Before starting PHP programming, however, it's essential to ensure that a web server is running, whether locally through software like XAMPP or online through a hosting service. A web server is required to execute PHP code because PHP is a server-side scripting language. Without a server, your PHP code cannot run and will simply appear as plain text in the browser. The server environment allows the PHP interpreter to process the code and send the resulting output back to your web browser. Now that we've covered the installation tools and environments for PHP, let's discuss the different options users have for setting up and running PHP on their local machines. The image shows that there are 3 options to choose from, and we'll begin with option 1. In this first option, users can either install Apache and PHP individually from their official open-source websites or use a pre-packaged setup such as WAMP, LAMP, or MAMP, depending on their operating system. These all-in-one packages simplify the installation process by including everything you need: Apache as the web server, MySQL or MariaDB as the database, and PHP as the scripting engine, all working together automatically. Once the installation is complete, a few basic steps need to be followed. First, launch the Apache server and PHP from your system's program list. When Apache is installed, it creates a folder called www inside its installation directory. This www folder acts as the web root, where you will store all your PHP files and projects. Next, create and save your PHP scripts or project folders inside this www directory. Each PHP file represents a different web page or functionality that you can test locally. Finally, to execute your PHP script, open any web browser and type the following in the address bar: http localhost file name php here. Filename.php represents the name of your PHP file. For example, if you created a file called test.php, you would type http://localhost test.php to run it. This localhost address refers to your own computer, acting as a local web server through Apache. Regardless of where your script is stored within the www directory, the URL structure remains the same. This setup allows you to easily test and debug PHP programs before deploying them online. In summary, option 1 is the most straightforward and commonly used method for beginners and professionals alike. It combines simplicity with flexibility, allowing users to quickly install PHP, organize their project files, and run them in a local server environment using their browser. In option 2, users follow a slightly different approach to running PHP programs, especially when they are ready to move from local testing to online deployment. In this method, you install PHP and MySQL individually from their official open-source websites. After setting up these tools on your system, you can start writing and creating your PHP scripts locally just as you would in option 1. Once your scripts are ready, the next step is to find a web hosting service that supports Apache, PHP, and MySQL. Most modern hosting plans already include these components, which makes it easy to upload and run your PHP-based projects on a live web server. The advantage of this approach is that you are preparing your website directly for a live environment, ensuring it behaves the same way it will when accessed by real users over the internet. By using a web host that supports these technologies, your PHP scripts can be executed on the server, and the processed results can be viewed through any browser, just like a real website. This method is often chosen by developers who want to publish their PHP projects online or practice with actual hosting environments rather than just local testing. It also helps students and beginners understand how PHP works on live servers and gives them hands-on experience with hosting platforms. In short, Option 2 bridges the gap between local development and real-world web hosting by letting you test, upload, and execute PHP applications in a live, server-supported environment. In Option 3, users are provided with the simplest and fastest way to test PHP code without going through the installation process. This option is ideal for beginners who just want to experiment with PHP syntax or test small code snippets. Here, you can use an online PHP interpreter such as www.runphponline.com. This website allows you to write and execute PHP code directly in your browser. You don't need to install any software like Apache, MySQL, or PHP locally on your computer. All you need is a basic text editor to write your PHP script and an internet connection to access the online interpreter. Once you open the website, you simply paste your PHP code into the editor and click the Run button. The platform will then execute the code on its server and display the output instantly on the same page. This method is perfect for quick testing, learning, or debugging small pieces of PHP code. It's also very useful for students who are just starting out and want to see how PHP works without worrying about configuration or setup issues. However, there are some limitations to this approach. Online PHP interpreters are not suitable for large-scale or complex web applications. They have limited server resources and cannot handle database connections or full website testing effectively. Moreover, since your code runs on an external server, you might face restrictions related to file uploads, security, or execution time. Option 3 is best for light use and educational purposes. It allows quick access to PHP functionality from anywhere, making it great for learning and demonstrations. But for serious development, frequent testing, or real-world projects, using a local environment like XAMPP, WAMP, or a live web host is much more practical and reliable. Before we begin installing PHP on Windows, it's important to understand that there are different web server options available for running PHP. The most commonly used one is Apache, but there is also an alternative called Nginx. Nginx is a modern and efficient web server that is often used as an alternative to Apache. It's known for its high performance and ability to handle many connections simultaneously, which makes it popular for large-scale web applications. However, on Windows systems, setting up and configuring Nginx can be more complex compared to Apache. It requires additional steps and deeper technical understanding to configure it properly, especially when linking it with PHP. Therefore, most beginners and intermediate users prefer using Apache because it's easier to install, configure, and manage. 2.1.3. Installation of PHP on Windows 8.0 and higher versions with Apache. When installing PHP on Windows, it's essential to check the system requirements first. The minimum operating system requirement for PHP is Windows 2008 or Windows Vista, whether it's a 32-bit or 64-bit version. However, from PHP version 7.2.0 onward, support for Windows 2008 and Windows Vista has been discontinued. This means that if you're using a newer version of PHP, for example, PHP 8.0 or later, you must have Windows 8.0 or a higher version such as Windows 10 or Windows 11 installed on your system. These newer versions ensure better compatibility, faster performance, and fewer security issues. In this session, we will focus on how to install PHP with Apache on Windows 8 or higher, as this is the most stable and beginner-friendly setup. The process involves downloading both Apache and PHP, configuring them to work together, and then verifying that your setup is working correctly. By using Apache, you'll be able to run your PHP code locally, test your web projects efficiently, and gain a proper understanding of how a real web server handles PHP scripts, all from your personal computer. Before PHP can run properly on a Windows system, it requires a specific supporting component known as the Visual C Runtime, CRT. The CRT is part of Microsoft's Visual C++ redistributable package, and it contains essential libraries that allow PHP and many other programs to execute correctly. Since most Windows applications rely on this runtime, there's a good chance it may already be installed on your computer. However, if PHP fails to run or throws an error related to missing DLL files, it usually means the correct version of the Visual C++ redistributable is not installed. Most recent versions of PHP are built using Microsoft Visual Studio 2019, which means they need the Visual C++ redistributable for Visual Studio 2019 to function properly. Users running a 64-bit version of PHP should download and install the x64 CRT, while those using a 32-bit version of PHP should install the x86 CRT. These redistributables can be downloaded directly from Microsoft's official website. When installing the redistributable, users may come across certain command line options like nor start or quiet, which simply control how the installation runs. For example, to prevent automatic restarting, or to install silently in the background. Once the CRT is properly installed, PHP will be able to execute scripts smoothly without any compatibility issues. Additionally, for users who are using Internet Information Services, IIS, Microsoft's own web server, and want to run PHP, the easiest method is to use the Microsoft Web Platform Installer, WebPI. This tool automatically downloads and configures PHP, along with all the necessary components for IIS. It simplifies the process of integrating PHP with a Windows Server environment, saving you from manually setting up configuration files or linking PHP extensions. In summary, before running PHP on Windows, ensure that the correct Visual C runtime, CRT, is installed. Without it, PHP will not function properly. And if you're working with IIS, using Microsoft's Web Platform Installer is the most convenient and reliable way to set up PHP quickly.